All right, so looking at exam 2 number 6, we're gonna work through all these problems. So, the position of a moving particle given by S of t equals t cubed minus 9t squared plus 15t. The particle is moving in feet where east is the positive direction, so S of t has to have the positive slope, where that's going to be found with v of t. Let's mark that down. And t is measured in minutes. Keep in mind that time can only be positive after start. So t can never be a negative number. So t cannot be, just cannot be a negative number. D. Awesome. So first find the first and second derivative of S of t. The first derivative of S of t is going to be v of t, and that is 3t squared minus 18t plus 15. And then S double prime of t, or v prime of t, is equal to the acceleration. So that's going to be a of t, and that is equal to 6t minus 18. Awesome. Knowing this, if the first derivative is the velocity equation, when is the particle at rest, right? So to find when the particle is at rest, set v of t equal to 0, and then we solve for t. So let's set v of t equal to 0. V of t equals 0, right? So that's going to be 3t squared minus 18t plus 15 equals 0. First, what we're going to do is we're going to take out the 3, 6t plus 5. Now what's x factor? 6, 5. So what here is going to add up to 6 and multiply to 5. That's going to be negative 1, negative 5, right? So we're going to do x minus 1 and x minus 5. Awesome. Now we find the x, what the x equals. X equals 1 and x will equal 5, and at t equals 1 and when t equals 5, the particle will be at rest. Awesome. So now C, algebraically determine where S of t is decreasing. Since t equals 1 and t equals 0, since t equals 1 and t equals 5 are zeros, they won't have a slope. So let's draw sign charts to see the signs of the slope before and after the points t equals 1, 5, and 0, because that's our start time. Here's 0, here's 1, here's 5. And these won't have any slopes because they are our zeros, right? So let's check in between. Let's put in 0.5 into the velocity equation for this interval here. And then v equals, let's say 2 for this here, right? And then v6. Now let's solve all these out. V of 0.5 equals 3 times 0.5 squared minus 18, 0.5 plus 15. This is going to equal out to 3/4 minus 9 plus 15. And all this is going to equal a positive number. Now let's look at V2. 2 squared minus 18, 2 plus 15. Right, so this is going to be 12 minus 36 plus 15. And these two equal 27, which is not enough to make it a positive number, so it is a negative number. Now let's look at v of 6. 6 squared minus 18, 6 plus 15. Alright, so this is going to be 3 times 18. minus 18 times 6 plus 15, and this is also, this is not also a negative number. Let's do the math for this one. This is going to be 18, this is going to be 36, minus 108 plus 15. 3 times 36 equals 18, that's 9. So 108 minus 108 plus 15, this is going to be a positive number. Alright, so this is going to have a positive slope, this is going to have a negative slope, this is going to have a positive slope. So S of t is going to be decreasing from the interval 1 to 5, proven by right there. Awesome. Now, on what intervals of time does a particle move in the east direction, right? And we were told earlier that when S of t has a positive slope, it is moving in the east direction, right? And so from 0 to 1, it has a positive slope, and from 5 to infinity, it also has a positive slope. So from the particle is moving east on the intervals 0, 1, union 5, infinity. Awesome. So that is D. Now let's go on to 6E. On what interval does the particle have a positive acceleration, right? So let's make a sign chart with the new, or let's make a sign chart, and instead of using V of t, we're going to be using A of t, which is, let's refresh ourselves, 6t minus 18. 6t minus 18. Let's set this equal to 0 to find where our 0 is going to be. 18 equals 6t. T is going to look like it equals 3, so 3 here. Now let's find A of 2 and A of 4. So A of 2 is going to look like 6, 2 minus 18, which is going to be a negative number. And then A of 4 is going to look like 6 times 4 plus 18, which is 24 minus 18. That's a positive number. Awesome. So from 3 to infinity, it will have a positive acceleration. Okay, using the information from A to E, determine the time intervals when the particle is slowing down. To do this, let's first copy down both our sign charts, and when the sign of the slope matches, it's going to be speeding up, and when it doesn't match, that means it's going to be slowing down. So we know that for 3, this is 1, this is 5, right? So it was decreasing here, increasing here, and increasing here, if I'm not mistaken. Up. Yeah. And then it's going to be decreasing here and increasing here. So when the sign isn't matching, that means that it's going to be slowing down. So from here to here, and from here or here to here is when the signs aren't going to be matching. So the intervals on when the sign is going to be matching is from 0 to 1 and from 3 to 5. Now for G, to find or what is the total distance of the particle traveled during the first 8 seconds? Just to find the particle distance, we want to put t equals 8 into s of t, right? So s of t equals t cubed minus 9t squared equals t cubed minus 9t squared plus 15t. Now we just put t equals 8 into here. So s of 8 equals 8 cubed minus 9 8 squared plus 15 8. All right. And after we put 8 in, we solve it and you should get 56 units.